This one, and the end correction is what? E. And let the pressure, the displacement amplitude of wave which will set up, let it be A. So what is A? Amplitude of longitudinal wave that sets up standing wave in a pipe. I want the pressure at the midpoint of the pipe. Find the excess pressure at the midpoint of pipe. The end correction, instead of this end correction, I'll just say that radius of the pipe. You must understand. What is R? R is the radius of pipe. L is length of pipe. R is, it didn't say end correction is there, but if mentions radius of pipe means end correction will be there, no? Let me give that value of L, length of the pipe 10 centimeter, length of the pipe 42 centimeter, radius of the pipe. Usually they give diameter. I directly giving the radius of the pipe. Find the excess pressure at the midpoint of the pipe. Now, what is the air column? Vibrates in the second overtone. The air column. How to do? So directly, let me jump into second overtone. What shall we do? How many loops? Closed-end organ pipe, no? You can see that it's a closed-end organ pipe. So we'll go for the displacement or the pressure wave will go it. So pressure antinode should come and the pressure node where it should be. Shall I go for at the open end pressure node or on the right side of the open end? Because the end, this radius given. If I don't give radius of the pipe, then you have to neglect end correction. Am I right? Since the radius of the pipe is given, you must consider end correction. So where that node will be there, pressure node will be at open end or on the right side of open end, right side of the open end. This is what the mistake usually we do. So this will be, you have to extend it. This should be the method, no? And this is what we say end correction. Am I right? So then what is this? This data, this will become lambda by 4, lambda by 2. This will be lambda by 2. Where is the midpoint? Where the midpoint will come? L by 2. So if you see this 2.5 loops are there. This is antinode, antinode. Okay, am I right? And this is antinode. So there's a node. So we are talking pressure node. Huh? There's a pressure node, pressure antinode. The distance between adjacent node antinode will be lambda by 4. So that this will be over. So he is asking pressure here. Midpoint is telling. So what is the midpoint? L by 2. Exact L by 2 is what? Is asking the excess pressure. Let me define this is x equal to 0. No, what is the pressure equation? We do write like this, no? Delta P of x should be equal to 2 BAK cos kx. Am I right? Don't fight with any of the concept here. Directly come for this particular thing. Then what is L plus E should be? L plus E should be lambda by 4, lambda by 2 plus lambda by 2. 5 lambda by 4 is what? L plus E. We know L and E, but we don't know E, no? What is E? 0.6 R. So from that, I'll get the expression for length. So 42, 5 into 0.6 will be 3. Anybody lambda? 45, 5, 5, 9, 36. 36 centimeter will be the lambda. If you know that k equal to 2 pi by lambda, we'll get the value of k. What is k equal to? 2 pi by 36 or pi by 18 per centimeter. I'll give bulk modulus value. Amplitude of the displacement wave will be very small it is, so it will let me put 0.02 centimeter. Let me supply all the things. Okay, now we know the value of k. What shall we do? K, I'll write it as k value, I know it, pi by 18. What shall I write x? Anybody? L by 2. I think problem solved, no? Very simple. You need not to fight with anything. We know all the values, you'll get the x expression. These are the types of questions will be there for you. So now we are in a better position. No, we can find out what is the pressure if they ask you P naught plus this value. So, sir, is he asking at L by 2? No, definitely you can check it. No, so there's a anti. This is what note. This cannot be equal to this distance. No. So is it L by 2? Somewhere it lies here. Am I right? Check it. L by 2 will lie somewhere here. The point where he's asking the excess pressure is asking somewhere here in this region. Huh? He's asking somewhere in this region. Not at this point. If it is at this point, I know 2 BAK. Pressure at antinode is how much? Excess pressure, 2 BAK. Pressure at node, excess pressure is 0. At antinode, it will be 2 BAK. What about here? It will be different, no? It will vary. It decreases. He's asking somewhere here. So for that, we have a formula. You need not to fight with anything, no? Take help of this formula. Substitute, define. Sir, why you write cos kx? If I say x equal to 0, so what shall I write here? Because what is the pressure should be, excess pressure should be maximum, no? 2 BAK. Standing waves on a string, what you did, the same concept you should apply it. Solve this, you'll get the required answer. These are the types of questions they can ask you to calculate the pressure or excess pressure at any point. And what is the pressure at the open end? Not P naught, it should be P naught plus certain value. How to calculate? Put x equal to L. That's all, no? So let me ask you pressure at open end. P naught plus 2 BAK cos. Substitute the value of L, you'll get the required answer. Excess pressure at midpoint of pipe. That is what we expressed here. Got the idea, no? So we can calculate pressure at any point also. Excess pressure means only delta P. If you ask a pressure means P naught plus mean atmospheric pressure plus excess pressure, what? The total pressure there. Okay, we'll end up the class. I had to go to college, no? Okay, thank you, all of you. Yeah.